Hi, welcome to my talk about A/B testing, how to A/B test with confidence. So this is me, I'm Fred. Ideally I'd be with you today, but unfortunately I'm not. I'm currently about 100 kilometers north of London. I'm here with my cat slash fairy pillow. And just a little bit about me. So I'm a long-term Rubyist. So I started off back with Rails 1.0 many years ago. I'm currently the CTO at Recipe. We do a lot of things to help clothing retailers. But what's relevant to this talk today is we do a lot of personalized content for them. So we help make emails be individual to people. We help make banners of recommendations be personalized based on your behavior and what you like. And so we do a lot of A/B tests around that content that we supply. So the plan today is a quick recap. So, what is an A/B test and why do we do them? And then we're going to go over some of the things that can go wrong with A/B tests. So when you're setting up the test, while you're running the test, and when you're analyzing the data. And then we're going to finish off with a bit of information about how we do tests at Recipe and some best practices to end on a high. So what is an A/B test? Well, you start with a decision you want to make, and you want to make that decision in a data-driven way, so not just based on a hunch. So commonly, what color should this button be or what should it say? Then you randomly assign people to groups. Those two groups get the two kinds of content that you've devised. And the key thing is, although lots of things may affect the result that you get, the percentage of signups or the amount of money you make, anything that's outside of your control should affect those two groups evenly. And then you measure the difference between the two groups. And although very classically the difference is something like, oh, what font should I use or where should I put this button? A/B tests aren't just about buttons. So you can test all sorts of UI elements. So as well as just a change to a button, it could be completely different layouts or designs. It could be a completely different flow. For example, the checkout flow on an e-commerce website. You can A/B test algorithms. So say you're Netflix, you could have different methods of choosing which recommendations you show to people when they're browsing for films or for TV programs. You can even A/B test things like pricing or how you position things to customers, and really anything where you can measure a difference. And that difference, as long as it's measurable, doesn't matter what it is. It could be conversion rate. If you're Netflix, you might be more interested in how long people spend watching videos. As long as you can measure it, it doesn't really matter. Once you've got that difference, obviously the key question is that difference real? Or is it just a random fluctuation between the two groups? So the concept here is significance. And what that really means is, what is the probability that the observed difference is just noise? So people will say, oh, we want a p-value of 0.05. That means you want the probability that the difference is random, it's not a real difference, is 0.05. People often speak about that the other way around. So instead of saying 0.05, let's say we want to be 95% confident that the difference is genuine. So you have to do some maths to calculate that. I don't want to go too much into that detail today. There are a lot of online calculators for it. The key thing is the statistical test, so the computation you do on your data to get that significance value depends on the type of metric. It's not the same for a conversion rate than it is for an average spend per customer, for example. This site here, evanmiller.org, has a lot of great resources for A/B testing, including several significance calculators. The second kind of definition / math concept I want to talk about is test power. And that really means is how small a change do I want to be able to detect? The more powerful the test, the smaller the change. And just by way of intuition, what it really boils down to is it takes a lot more data to measure a 1% change than a 10% change, for example. That 1% change will be very easily overwhelmed by just random noise, whereas a 10% change or a 20% change is much easier to see. So if you put those two concepts together, test power and test significance, you can calculate the sample size. And what that is that how many users should you put through your test to be able to detect a change that is significant at a certain level and is of at least X%. So in theory, this is all very simple. A small bit of maths, run an experiment, plug numbers into a calculator, and you get a result. But let's see what can go wrong. So test setup. So the first thing you have to do is randomize people into these two groups. And that is so important. If that doesn't go right, the numbers you'll get at the end will be meaningless. I wrote this code many years ago before we used the gem called vanity, which I'll talk about again later. We had a class called user. We wanted to put users into groups, be able to do A/B tests. And I was lazy, and I thought I don't really want to have new models to track which group each user is in for each experiment. I'm going to create lots of rows in there. That sounds like a hassle. I know what sounds random, whether the user's ID is even or odd. And that on its own might be relatively harmless. It's kind of hard to be completely sure, but I'm willing to accept that. The bad thing is that this AB group method, which returns, if the ID is even, returns experiment, if the ID is odd, returns control, is that we reuse this for a large number of tests. And what that means is that once you'd signed up and you've been given a user ID, you're either always in the experiment group or always in the control group. And that has an effect that's very difficult to measure on the tests. It's difficult to detach the individual tests that we were looking at to what is the cumulative effect of someone always being experimented on. So maybe the tests are really just telling us that if you keep changing, I don't know, the layout and the functionality for some users every week, then they engage less. But you can't really tell afterwards. You can't fix that data. Another example of group setup gone wrong is just a completely non-random split. So this happened to us with the test that was being run by a retailer with us. So they were in charge of putting users into groups. We were in charge of providing one of the variants. And we thought the group was random, but actually it was one group that mostly had their older users in it. People have been using that site for a long time, and the other group had much newer users. So we ran the test for a couple of weeks. And then after the approximate sample size had gone through the test, and we started analyzing the data. And the difference between the groups was huge. Way, way, way more than we were expecting, to the extent that we thought something is not right. We shouldn't be able to make a difference this big just by changing some products in a banner somewhere. And when we dug a bit deeper, we found that the groups had very different revenue before the test. So this was not a random split. And then eventually we were able to get the whole story out of the retailer. And again, when you have this kind of group set up that's wrong from the start, you can't really extract the truth from it afterwards. You can't really say, well, the revenue is this different before the test, and it's now slightly more different this way, therefore the test has gone one way or the other. It was just a waste of time, and we had to do the test again. Another kind of setup flaw can be what I'm calling starting the test too early. And the easiest way to explain this is to maybe look through what a typical conversion funnel on an e-commerce website might be. So I want to test a change to my checkout page. So obviously, I get some users that come to my website, let's say 100,000 users. Some of those users click through onto one of the category pages, look at shirts. Some of those users see something they like and they click on it. And an even smaller subset of users take that item, put it in their basket, and then goes through the checkout process. So by here, I'm down to 10,000 users. This is my test. I've got two different versions of the checkout page, 5,000 users in each. In one variant, I get 2,600 people converting, and the other variant, I get 2,500. And if you do the maths, this is significant. That 100 extra conversions over these 10,000 users is a significant change. So you might think, well, what happens if instead of putting people into the two groups and measuring the test on these 10,000 users, I started the test earlier on? So you could say, well, I've got these two groups, and they went to the product page. Each of these 15,000 users saw the same thing. And I can keep on going back like this. So actually, maybe this is a test where I had 100,000 users, and 50,000 users went down this route, 50,000 users went down that route. And if you do the calculations on this, so 100 extra conversions over 100,000 users, then this is not a significant result. And I think the intuition here is that what you're saying, are these variants different? Well, actually, for 90% of people, there was no difference between the two variants because they never made it to the bit of the site that had the change. So in general, you want to assign people to groups as late as you can, as close to the actual change. You want to minimize people being part of the test that aren't being exposed to the change you've actually made, or else just make it much harder for you to detect any changes. And then the last kind of setup error is is kind of a meta error. It's not agreeing the setup. And then by this I mean just being clear with people what you're actually trying to do. So what is the scope of the test? What pages is this change content appearing on? Is it running for all users, or is it running for users who create an account? If there's an e-commerce site, for example, that operates in multiple countries, is it all countries? Or is it just the English language version, for example? If you have desktop and mobile apps, are those included or not? It doesn't really matter what the answer is, you just need to be clear what it is. How is the test measured? So what is the metric? Are we talking about conversion, some form of engagement, revenue? Again, it doesn't really matter what it is as long as you kind of pin it down. And ideally, you want one metric. If you get answers of the form, well, the most important thing for us is revenue, but we'd like to keep an eye on conversion as well. You're setting yourself up for trouble later. Right, so let's say we've got a perfectly specified test and everything's set really nicely. What can happen during the test? I think the biggest thing here is that a test measures the impact of every single difference between the two groups. As the person implementing the test, it's very natural to think only of the differences you've introduced on purpose, that different layout, for example. But there may be other ones. And for this, I'd like to talk about a test that I was involved in a few years ago. So a retailer had a mobile app. Fairly standard e-commerce type mobile app. You have your phone, it talks to one of their servers, it pulls back a list of products, it displays the products in the app, and you scroll through and hopefully you see something that you like. What we said to them is that we think we can, instead of you showing the products in the same order to everyone, we can provide a personalized product ordering. So instead of talking to your e-commerce service, make an API call to our recommendation service, and we'll return the right products to show. So in theory, that was the two variants. One variant sees exactly the same thing that retailer has always done, and the other variant gets personalized recommendations from our service. Unfortunately, the agency that implemented this test, they made a mistake in the code that was parsing our API responses. And as well as having showing different products because the products came from our recommendation service, this variant also had 10 times as many crashes. It wasn't a huge amount. It was coming, 0.5% of sessions had a crash instead of 0.005 of the sessions had crashes. But still, obviously, it's a very negative experience and has an effect. And we didn't know this until we analyzed the data much later on. But this test, even though we think it's just measuring the difference of the different types of products that are shown, is also measuring the impact of what happens to users if you make their app crash more. And spoiler alert, if you make apps crash more, users don't like that. And much like before, you get one result, variant A is better or variant B is better, and it's very difficult to disentangle past result from that. It's tempting to say, well, given that the app crashed so much, it's actually pretty good that revenue only went down by this amount. But you can't say that with any kind of rigor. So anytime there's a difference between variants that is not part of what you want to test, whether it be unintentional like this or just kind of changes that happen by accident, for example, to UI, be very careful. The other area I want to talk about here has a big name, repeated significance testing. And what this involves normally is normally your boss or someone higher up, coming to you and saying, so this test that we've been running for the past few days, what are the results like? Is it significant yet? And so you want to be helpful. You take a look, you run through the calculator, and you tell them the answer. And this seems very innocent, which is why it's so subversive. Because if the answer is yes, the result is significant, and then you'll say, oh great, the test is over. And if not, say, well, yeah, it just hasn't reached significance yet. We'll just come back and they'll be back the next day or 3 days later asking you again the same question. And really, this invalidates the significance calculation because significance never tells you that it's 100% sure that something has happened. We're telling you that it's 95% sure. And effectively, what you're doing here is you're just re-rolling the dice. You're buying more lottery tickets until you get the result that you want. It is difficult to resist. But stay strong. So let's hope that maybe you've avoided all these errors. You run your test, you've reached your sample size, and now it's time to analyze the test. There's things that can go wrong here, unfortunately. So you should be trying to do first is to do the maths. So that means use the appropriate statistical test. Testing on conversion is not the same as testing on retention, is not the same as testing for revenue, or testing for average amount of time spent engaged with your app. These are all different types of metrics, and they all have different statistical tests that you should perform. And if there's one thing you remember from this, it should be this: that significance on one metric does not imply significance on another. So what I've seen many times is people are using a tool. That tool can calculate significance on one type of metric, very often conversion. It can't calculate significance on revenue, because that's a bit more complicated. And what people will do is they say, well, it's significant. This test is significant on conversion, so I'm going to assume that means that the revenue change is also significant, and that's not true. So another thing that could go wrong with your test is this guy. So this is Bill Gates, and you might be wondering, how can Bill Gates screw up my A/B test? Well, let's say you're a charity, and you have a web page where people can find out about your charity and they can donate money to your worthy cause. And you're currently running a test, and the thing that you're interested in measuring is how much revenue do you get. So that's what you're trying to measure. And then Bill Gates comes along, he plays around with your site, and he donates $1 million because he's a generous man and he's a very rich man. And for you're a small charity, that's a huge amount of money. You're expecting that over the course of this test, maybe a few tens of thousands of dollars, maybe $100,000 if you were really lucky. So whichever group Bill Gates lands in, he's adding $1 million to that group, 10 times what's in the group already, and that group is just going to win the test. It's no longer about, is this change, considered over 10,000 users, which change is slightly better? It's just going to be, what did Bill Gates like better? I mean, Bill Gates actually only even saw one variant, so you haven't really measured what you thought you were, and this one outlier is distorting your test. So with metrics like revenue, it's worthwhile considering, what is a normal user and what is an outlier, and consider eliminating outliers. But agree about this before you start the test, not afterwards. Which kind of brings me on to my next topic, which is resplitting results. So it's very tempting if you run a test and it's not significant or it's not the result that you wanted, to say, well, okay, overall, this test hasn't worked the way I wanted to. But what if we look only at mobile users? What if we eliminate some outliers? What if we only look at new users? What if we look at weekends only? You can always come up with a split that sounds plausible. And you can often find a result that is the result that you wanted. And kind of that's the problem. It's like looking at this test, saying, is blue better than red? And this looks kind of random to me. They look about the same, and saying, well, if I ignore all these gray ones here, then the result is significant. And you can always kind of pick the result you want. And if you do the stats on this subset of data, then it probably is significant, but it is just you manufacturing a result. So you can get an insight like this. So maybe when you look at the data, you find that actually very odd things happen on mobile, and maybe you did make a mistake there. So you may well gain an insight. But the thing you do with that insight to then say, well, actually, let's run another test. Maybe it's the thing that guides you towards, for example, the crashing bug that we had earlier, or it's the thing that guides you to a change that you then make. But then you have to run that test again. You can't kind of leap from the split result to a real result. But the biggest kind of problem with the analysis is kind of a human level problem, which is that by and large, we aren't neutral. In the trivial examples, people talk about, what color should I make this button? You probably don't care that much what the winning result is. It doesn't matter to you. You're not personally invested. But if you've spent 3 weeks designing a new landing page, if you've spent several months designing a new algorithm, you really want that work to be worthwhile. You don't want to run the tests and for the result to be, well, actually, the old page was better. Let's just go back to that, throw away 3 months of your work. So you're very biased often towards one of the outcomes. And if you run the test and you get, the quote unquote right result, the one that you wanted, then yeah, everyone celebrates, the test is over, and we move on. But if the result is wrong, then people are much more likely often to start looking at things like result splits, to start digging for errors. This is the point at which I hope that your test is well documented when you made very clear ahead of time what the metrics were, what your policy was considering outliers, for example. And it's not really a silver bullet here. You just have to try and apply the same rigor whatever the result is. So let's talk a bit about A/B tests at Recipe. We have two kinds of tests that we run principally. One are internal tests, tests that we run for ourselves to improve our product. These are typically algorithm changes. And we use Vanity for allocating people to groups and making sure that people see the correct variant of content. We don't use Vanity for reporting. The main reason being that Vanity doesn't support all the types of significance calculations that we want. So you might remember this slide from a few minutes ago, which is my faulty AB group setup. So this is a bad way of doing it. The kind of modern version of this in our code base looks like this, and I'll talk you through it quite quickly. So this is class AB test workflow picker, and in our code base, the workflow picker is a thing that says what algorithm should we use to recommend you content. There are lots of different reasons why we might choose one algorithm or another, a different context, different placements, and so on. But one reason is we're running an A/B test, and that test is going to decide what algorithm you get. And this class has to implement one method, which is pick recommender workflow. So please return me the name of the algorithm to use. We pass a profile, so who is this test for? You tell Vanity what the context of the text is, who is the thing that decides the identity. So very often there's something like current user. And if you run your test in a controller, then Vanity comes with a helper that will do that for you. But this isn't inside a controller. We fetch the experiment. So each A/B test workflow pick is associated with a Vanity experiment. And then we ask the experiment, please tell me what the value is. And this is the thing that will take care of saying, well, given that this profile, I should pick one value at random, then I should keep returning that same value, even if the person comes back to the same page again. And this will also record which group everyone is in so that we can do the analysis later. And the other kind is our external tests. These are typically of the form, if we add recipe to a page, does it increase something? And these are much more complicated, typically because the responsibility is split across multiple parties. Either way, we have some Python scripts to calculate different types of significance, and we always run a setup document for each test, which we'll talk about in a bit. So lastly, some best practices. I'll start off with don't reinvent the wheel. Things like Split and Vanity, they do good jobs. There are online tools as well. Avoid those test setup errors. But you still need to understand what it's doing. You should understand how your tool is allocating users. If you're using their significance calculation, you should understand what it's doing and if they're appropriate to your data. Resist the urge to check and tinker. So this is repeated significance testing, which we did talk about. Is also making other types of changes. Like maybe you spot a small mistake in your code after the test has started. If you need to fix it, then you have to restart the test. AA test. So this is like an A/B test, but both variants see exactly the same content. And you run through the full process. This is a great way of allowing you to practice. And if you do have problems with how you set up or measure tests, then this will help flush them out. Because if you spot a difference between A and A, then something has gone wrong. Be wary of over-testing. Maybe you'll come out from this talk full of enthusiasm about tests. I hope so. But don't go to the let's test everything. A/B tests take a while. It takes time to set them up. It takes time for the test to run, often days or weeks. If you run every single decision through that, that's a paralyzing and time-consuming process. They increase QA and spec burden. You have now 2 branches to test, and if you have multiple A/B tests running at the same time, that's more and more combinations. And lastly, they're not a substitute for vision. You need to understand where your product is going. The A/B test is not going to tell you this decision hurts you in the short term, but it's beneficial in the long term. you still need to understand your product for that. So yeah, they don't help long-term planning in the same way. And lastly, document your test. This is kind of the most important thing, really, of these practices. And this slide is pretty much our checklist for that. So what is the metric that you're measuring? What is your policy around outliers and so on? What is the success criteria? Like, is the test a success? Are we going to switch to the new variant? Under what circumstances? It might be you're just trying to show that you haven't made things worse. Or maybe you're saying, well, we need things to be at least 2% better. Again, it doesn't matter what it is, but you should agree this ahead of time. Scope, so we mentioned that before. So is it running on all platforms? Is it running in all countries? Whatever it is, agree it. Sample size and test power, do those calculations ahead of time. We've had tests where we've started planning out the test and then realized it would take 3 months for the test to run. And that from a business point of view, that wasn't acceptable. A significance calculation process. So, write down how you're going to do that. Let people challenge you to say, actually, I don't think that's the right process given the metric you're measuring. And meaningful variant names. I mean, this sounds ridiculous, but we had a test once where we'd been working with a retailer for 6 months, and someone said, actually, wait a minute, we should have done an A/B test at the beginning of this. I said, okay, we'll run the test now. And so this was a test where we were adding content to the retailer site, and fully half the people involved thought, well, the recipe content has been on the site already for the past 6 months, and now we're running an A/B test. So clearly, the test, the experiment branch of the test is removing recipe from the site. And 50% of people were in the mindset of, well, if we started out doing things the right way, we'd done the A/B test first, and then the experiment would be adding recipe to the site. And we only noticed this when people were quite far into those discussions. Yeah, and then really, that's my last tip. So thank you very much, and hope to see you in the speaker rooms.